Okay, so hello everyone. This is the editorial for Deltix round Codeforces like which was conducted today. So directly starting with the first question, divide and multiply. So in this whole editorial, I'll be assuming that you have read all the questions, which I'll be discussing that time. So let's see the first question. So the idea for the first question was pretty simple, as they said that AI must be a multiple of 2. One second, I'll just open my solution. As they said, AI must be a multiple of 2, and then you can pick any j and then multiply it by 2. Like you have to first divide by 2, and then you can pick up any element. It can also be the same element, and then you can multiply it by 2. So the idea behind this question was first you have to find how many times were you able to multiply number. For example, 4, the count would be 2, because 4 divided by 2, 2, and then 2 divided by 2, 1. You cannot divide 1 further. So 4 you can make it as 2, and then 2 will be 1. Similarly, let's say we have 8. 8 you'll be making it to 2, then 8 you'll be making it to 4, then to 2, and then to 1. So here the count is 2 because you were able to divide it by 2. Here the count was 3. So like this, first you have to store all the counts. So let's just say in the array you have 4, 8, 16. So the count for this would be 2, count for this would be 3, and then the count for this would be 4. Total count being 4, 5, 6, 4, 7, 9. 9. So now you can say that you have a total of 9. like you have you can say that now you can pick up any number and then multiply it by 2 raised to 9, because it's the same thing, because they told you that you have to multiply it by 2 you have to divide it by 2 and then you have to multiply it by 2. So what you did was you first divided all the numbers by 2, like all the possible thing to divide by 2 you did it. Like you got 4 to the lowest term 1, again you got 8 to 1. Even if there's something like, let's just say 6, you'll divide it by 2 and get it to 3. So the first you got all the numbers to its lowest form where it cannot be divided further by 2, and then you have some 2 raised to x. You have some 2 raised to x stored, some 2 raised to x stored, and now all you have to do is pick up a number and then multiply it by 2 raised to that x and see which one is giving you the maximum one. So the implementation is pretty simple. Just if n is 1, that just simply see out that element because nothing can be done. Otherwise just sort it. Count is 0, this count is this thing, this 9 which I showed you over here. Sorry, I'll just zoom this count is that thing, this 9 which I showed you over here. Then simply just iterate over all the elements, and as the constraints were too small, you can just simply run this while loop under this. Then you just take the array of the whole. So now you have all the elements to its lowest form where it cannot be divided further into 2. So just take the sum of that lowest term array. Now all you have to do is you have to, like, for the max sum, because you actually have to see out max sum, all you have to do is just make a temp sum, subtract that element. So let's just say I have 2 raised to 9 in my hand. Now it's in my hands where I should use this 2 raised to 9. So suppose that I have some element x, y, z. So sorry, let's just say after dividing all the elements by 2, I have elements as 1, 3, 7, and 11, because actually 11 was 22 but you got it to 11. 7 was, let's just say, 28 and you got it to 7. So doing all those things, you have 9 left. So it's in your hands what you have to do now, and the sum I have here is 1 plus 3, 7, 18, 21, 22. You have that as 22. So now I'm iterating over all these elements which cannot be further divided by 2, and you are subtracting 3. you're sub just an example, you're subtracting 3 and you're adding plus 3 raised to 2 raised to 9. This means that you chose this number to be a multiple of 9, to be multiplied by 2 raised to 9. Then you'll again compare the sum. Then you'll move on to the next element, 7. Then you'll move on to the next element. You will do minus 7, and then again you will check plus 7 into 2 raised to 9. Plus 7 into 2 raised to 9. And then again compare the sum. Similarly, you'll be selecting the maximum one and then see out as maximum. So this was a question. So let's move on to the second question. Okay, so yes, so in this question, I hope you all read the question. So in this question, it was you don't need ABC substrings. You don't need ABC substrings in the main string. So the idea I used here was, for example, I'll just show you the code. It would be much simpler that way. Okay. So what I did here was first I calculate ABCs in the actual string, like the string they have given over here. First I calculated the number of ABCs, like this count is the number of ABC substrings in the actual string. Then what I did was I took all the queries, IDX, I got it into a zero based form. And if they're saying that SID, like if they gave me an index, for example, they gave me index 1 in terms of zero base, they gave me index 1 and they want it to be B. So that way it doesn't make any sense. You just simply see out count because that's not making any further changes in the array, like in the count value. But the actual things come when so now suppose this isn't happening and you have to change a string, like you have to change a particular uh, a particular index to some different character, for example A to B, B to C, you have to change. Then what you will be doing is you will be iterating over that index. For example, where do you have to iterate? So suppose you have these let's just say five to six positions, and this was B. um 1 second. Okay, yes, so let's just say you had this as A, B, C, A. So and they gave you that you have to change this position to A. You have to change this position to A. So this position, as they said, they don't need substring of ABC, and ABC is actually of length 3. So you are only concerned with three strings. This string, then this string, let's just say we have B over here, and this string. Because these are the only three strings which have this character. If you do any changes to this character, it will only affect these three strings. So what I'm doing is I'm iterating over these strings, this string, and this string. How I did that? I just went from IDX minus 2 to IDX and I took the substring I to 3, and if that string is ABC, now as you know that you are changing this C to some other character, that ABC will no longer be there. So you have to minus your count. What was count? The number of substrings ABC count. Now you have to subtract it. After subtracting it, you have to set SIDX equals to C. Now you have to set it to, now you'll again set it to A. So a better example would be like you'll be okay. Okay, so yeah, so you have to change it to the next character, and then you'll be again running the same thing. Like you'll so like this is easy to understand. First, you're running it to check if ABC already exists, because if it already exists, it will no longer exist anymore. Then you're subtracting count. Then you're changing that index to that character, and then you are again iterating over that. So now if you get ABC, that's a new ABC, because earlier it wasn't there, and then you change this element to something else and you got a ABC though. So that's a new ABC that's going to increase your ABC count, and then you have to simply see out it. So this is the only thing concerning iteration of 3, and this won't cross the time limit because this is maximum big of 3 only. So yeah, so just first check if ABC already exists. If it exists, it will then no longer exist because you're changing ABC. And if you change any one of ABC, it will obviously change the count, because there's no way that you're changing it and the count won't change. And again, change it, and you never know what's going to happen. So there is a possibility that, as I said, there are three strings, so you never know which one will change to ABC. So then you have to run it again, and then you have to check if there's any new ABC, and then you have to update your count because that's a new ABC you got. So yes, this was the B question. Let's move on to C. Okay, so this was C. Again, I hope you all read the question. So in C was like it was a bit it it was a good observant type question. Like there was a very key thing to observe. So if you just sit back and just make array, like what all sequences are possible, no matter what the E is, because that's implementation. When it comes to E, so this is implementation, but you are actually concerned with what sequence is valid. There's only one kind of sequence you'll observe. For example, and they said it's a prime number. So there's no chance that you can say that in my sequence I have a 19 and an 11, because 19 into 11 won't give you a prime number, because then it will have two divisors. So it's obvious that you have to have a prime number, and along with that you only can have one. You cannot have any more number, because then the product, if you have any other number, for example, let's just say p1 and p2, then the number you are getting, the product, won't be a prime number anymore, because it's a product of two numbers. And as you know, prime numbers they only have two divisors, which is the number itself and one. So one thing is clear, that you need a prime number and a one. So now, one second. Yeah. So now let's just check what all possible sequences are there. I can say that one, let's just say this is a prime number. 1p is a possible sequence. 1p again is a possible sequence. 2p, no, it's not a possible sequence, because 2 into p would give you a number, and 2 will be its divisor. Therefore, 2 and p, there are two divisors with one, total of three divisors. Therefore, you can't have that number as a prime number. So you cannot have 2, you can have 1. So let's just go to the right side. Again, you can have a 1. Can you have 3? No, you cannot have 3, because the product won't be a prime number. Can you have a 1? Yes, you can have n number of ones over here. So the sequence is always something like this. It's 1, P1, then again 1, 1, P1. It's always going to something, a series of ones, and then again a series of ones, and in middle there will be a P. There cannot be 1, 1, because 1 is not a prime number. So now you must have gotten a pretty clear idea what to do. You only have to find suffix ones and prefix ones, and how you're going to find it, that we'll see in the implementation. Yeah, so this is the implementation. You'll take an e, you'll take in there, and then you'll make a prefix and suffix of the ones. For example, you'll be iterating over the whole array, and if arri equals 1, if arr if arri equals 1, then the main rule is to check how many ones are there, like how many prefix ones are there. For example, I have this, 1 second. For example, I have this, and then there are e distance difference over here. There's a difference of e, and then again here. Suppose you have 1 over here, and then 1 over here. So if I take in so now what I'm doing over here is I'm iterating over it. 1 second, where's the code? So I'm iterating over it, and then, for example, so I'll just explain this code, and the suffix is similar to this. So if arri equals 1, so as you can see, we have 1 over here, but I cannot go. So let's just say e is 3, but if I go 3 over here, like it will be out of bounds. So I have to check if i minus e is less than 0, then just set that prefix I to 1. So the prefix I here would be 1. Then we'll traverse, and let's just say we are in this one. So I will again check. So now I minus c is not less than 0. So I will go to prefix of I minus c, which is this, and then I will do prefix of I minus c plus 1. This is the pref array, which I'm making over here. Then you will make it as 2. So this is how you'll be making a prefix and suffix with a gap of e. You have to maintain that gap of e, because prefix suffix is simple, but here you have to maintain a gap of e. You can't just go 1 1 1 1 1. You have to maintain a gap of e. So therefore these two are the variations to maintain the prefix suffix gap, I minus e and I plus e. Similarly, in the suffix array, you have to see on the other side. Therefore, I plus e should not go out of bounds, and if it's not going out of bounds, the suffix of I plus e plus 1. So this is a sieve algorithm. Like, you can just Google it. It's sieve is used to, like, it runs with a time complexity of n log n, and it's used to see if any number is prime. So yeah, you can just pre-compute this thing, and then okay. So then after you have done that, as you can see, okay, so it's gone right now. So, like I said, you have to have a P111, again a P111. So let's just say after iterating, you just check if it's a prime. You check it's a prime. Then this left val and right val, these are the number of ones on the left side and the number of ones on the right side. If I minus e is greater than equal to 0, then you have prefix, otherwise you don't have any ones. You don't have which, so this has, so one thing I forgot, everything has to be at a distance of e. This has to be at a distance of e, this has to be at a distance of e. So if you're at a current I, that is p, you have to check at I minus e. You have to check at I minus e. So if I minus e, you'll get the prefix, like how many ones are there on my right hand side, sorry, on the left hand side, with a gap of e. Similarly for the right hand side, and if it's going out of bounds, then it's 0, then you don't have anything. After you got the left val and the right val, so this is just, so this I'll explain once. For example, you have this p, and you have a total of 1 1 1 over here and a 1 1 1 over here. So the so the possible answers are 1 1 p, 1 1 p1, 1 1 p, 1 1 1. Similarly, there are many. So basically, the answer to this is, the formula for this is 2 into, sorry, 3. I will explain why there are 3, because there is a possibility of p. But so these are basically the possibilities. How many ones can you take from left? It's equal to 1. You can either take 1 1, you can either take 2 ones, or you can take 0 ones. You cannot take any one. So that case is basically this p111. This is also a valid case. So there are 3 possibilities on the left hand side, which is basically number of ones on the left hand side at a difference of e plus 1. Similarly this plus 1. So basically 3 into 4. But as you can see that I did a minus 1 over here. That's to avoid 0 into 0 case. This p is not a valid case. You can just have p over here. So to avoid that, because as I said, there is a 0 over here. Similarly, what are the possible cases over here? It's 0, 1, 2, 3. But there is also a case where you'll get these two zeros, zero zeros. That doesn't make any sense because you cannot have p alone. So therefore, L plus 1, that is the left val plus 1 into right val plus 1 minus 1. This is the case I wrote, but I don't think it's needed. Just try without this. Yeah, so as you have the left vowels at a difference of e, the right vowels, the right ones at a difference of e, the left ones at a difference of e, subtract, just multiplied using this formula minus 1, because you don't want the case of 0 and 0, and then just simply see out the answer. So yes, so that's it. That's the editorial for the Deltix round. Thank you.